Okay, so good afternoon, everyone. This is Garnet speaking here, and I'm the technical support engineer of SuperMap. And for today, I will be the presenter for our SuperMap mini classroom webinar, and we'll discuss about the pipeline solutions, including for the 2D and 3D data integration, inspection, and maintenance management. But first of all, let me brief you a short introduction about SuperMap GIS software company. So Supermap was founded in Beijing in 1997 by Dr. Erzun Song, and for approximately 24 years, we have helped humans in solving various problems with GIS as the main foundation. And we have about 4,000 employees spreading in all around the world, 1,000 partners coming from then more than 30 countries, and also about 38 branch offices and subsidiaries. And the next is about the SuperMap 5 main key technologies. So there are five of our main key technologies that are the basis for solving spatial problems that encountered by using SuperMap GIS platform. Okay, for the first one is the big data GIS. So we support to do the whole process of big data, including from streaming data and then the storage management, spatial analysis, and also the data visualization. And we also have the artificial intelligence and GIS integration. So in SuperMap, we provide three main functions of AI. We call it the trilogy of AI. The first one is AI for GIS for AI, and also Geo AI. So if you ever notice that SuperMap can be able to do the object detection, feature extraction, it's part of the AI and GIS key technology. And the third one is the three-dimension GIS. So SuperMap able to consume various 3D data, able to analyze them based in desktop application or bring them to the web-based application. And we're also able to consume various data such as the data model, the scene construction, spatial analysis, and also the software form. And the fourth one is the distributed GIS. So this is one our new value just released in the last GTC 2020 last year, and we have our capability to manage the spatial computing in more than one machine, including for analytic, storage, and visualization as well. And it has four components. The distributed geospatial data engine, GeoBlockchain, distributed geospatial, that already released also last year, distributed geospatial analysis and processing technologies, cloud native and edge GIS technologies. And for the last part is the cross platform. So we are not only able to be open in Windows operating system, but also able to be open in another operating system such as Linux. And our product will serve in various terminal, such as in desktop, cloud-based, and mobile as well. And for today, I will be discussing more details on the SuperMap pipeline solutions for the 2D and 3D data integration, inspection, and also the management. Okay, now first, let me know about the GIS installation for pipeline maintenance and management. So, in this slide, I have summed up five common industry necessities for pipeline. So some industry have been utilized pipe as a main part of their business components, either to support their exploration or as the medium to provide services for their user. If we talk about pipe in such a very large scale of industry, I believe that some issues and necessities start to emerge. Some can be solved by business approach, and some need to be done by technical treatment. And here I have summarized the five necessities for a pipeline. The first one is the aging facilities need to replace or renew. So pipe is not a cheap stuff, right? So mostly it will be used for a very long period of time. A documentation of the pipe that store important information of them should be well documented so that we can replace or renew the pipe according to the condition that recorded. And the second one is if the industry scale is large, all of the assets and facilities really need to manage and record for upcoming utilization. So we need to manage the facility and also do some documentation for them. The third one, there's a regeneration for every company, of course. We need platform that could make sure the experienced engineers' knowledge is well delivered for to the younger generation. And then facility improvement for user. And the last one is the real-time inspection for mitigation and avoid worse accidents. So following up the previous necessities, the previous issue that encountered by user, SuperMap provide these four concepts as the pipeline management solutions. So GIS will not replace the oil and gas software, never. But by trying to solve the issues that are emerged using spatial approachments, we believe that we can offer these five solutions. Sorry, I mean four. The first one is the facility data management, emergency situation analysis, 2D and 3D integration, and the last one is the pipe modeling and analysis. And and who can utilize this solution? So as long as the industry is have pipe to manage and analyze them, especially, I believe they need this solution, such as the oil and gas industry, telecommunication, water supply, and many more. And now let's be discussing one by one about the solution that I already mentioned before. So the first one is the facility data management. So the data here within the facility data management mean data that have spatial information of it consists of the position, the coordinate system, and attribute information. So tabular data is not really convenient for analysis, right? Especially for spatial analysis. By mapping them all and overlay it with kind of informative base map, we can achieve not only the data management itself, but also experiences in knowing their distribution, scale, relative position to each other, and another insights. And moreover, by visualize them in such a 3D way, it will be way more convenient. And we are not stopped until the data management. In addition, should there are another data resources that can be coming from sensor, Internet of Things, or maybe employee reports, inspection results, and etc. We can add them all to the existing pipe data distribution to make it more informative, such as that presented in the presentation. We can do the pipeline performance monitoring, system function information, and data service platforms. So we are trying to integrate between the static data and also data that um, can be updating in a very tight time. Okay, next solution is the emergency situation analysis and simulation. So maybe even though only a simulation, but I believe that by simulate it in 3D, user will get more experiences and insight on how complicated or easy or impactful the situation it is. This will raise users' carefulness while in the emergency situation. The third one is the data integration. So the most wanted lately, we have the pipe data, but have no idea on how it located relatively to the object above. Data integration between upground and underground will be very convenient, especially if the pipe is closely related to the user's location or exploration site. And this one is more detailed on the example of the data integration. We are trying to bring the 3D data from desktop application into web-based application, and also integrate both of them between the underground data and upground data, as well as presented in this presentation. So that we can know what are objects above the pipeline. Let's say later on, if we are going to build new building, we can have a check first. What are pipe located under the building plan area. And another thing is the AR or augmented reality. So AR for way more better experience for user. Pipe is mostly or maybe all of them are located underground, right? So sometimes the staff need to do an inspection for a certain pipe, but then they dig the soil to find the wanted pipe will be very not convenient and not effective. And AR that could overlay the digital and real object as well as presented in this presentation will allow you to know where pipe is located. As But we need to set the scale of the object one by one so we can know we can make sure if the position and also the size of the object is similar or maybe quite similar with the real object. Okay. Okay, so we have discussing about the facility data management, emergency situation analysis, 2D and 3D integration in SuperMap pipeline management solution. So for the last part, the pipe modeling and analysis, I will show you in live demonstration on how to achieve this in SuperMap desktop application, or we call it SuperMap iDesktop. And actually, but it's not limit us to bring the analysis for web-based application as well. So in case you may need to develop a new platform, a new application in another terminal, not in desktop, you can bring the analysis and do further development to achieve that pipeline management or pipeline analysis application. Okay, this is now we move to our desktop to do the demonstration of 3D pipeline modeling and also analysis. And this is the software we will use for today, the SuperMap iDesktop.net, the 10.1.1 version that can be downloaded in link I have put in this presentation. But don't worry, I will share the material later after today's session finish, so you can download this slide and refer to the slide to download the SuperMap product. Or also you can go directly to our website to download the software, and it will be 90 days trial free in the beginning. And should you willing to extend the license for education purposes or other non-profit purposes, you can let me know and we can have a further talk to extend the license. And this is for the demonstration. I will show you for different processing. So the first one is 3D pipeline flow simulation. So we will try to create a 3D model of our pipeline and give some styling on that. So it will be very informative for us. And then do the single tracing elements analysis, critical element analysis, and the pipe burst analysis. And all of them will be done in SuperMap iDesktop. Okay, so now uh, I will stop the screen and okay, sorry, accidentally the virtual background is up here. So yeah, this is the illustration of SuperMap iDesktop, the latest version, the 10i 2020. So this is the first page you will find once you open the application. And to open the data source, the data source is SuperMap Spatial Database. SuperMap Spatial Database. You can right click in the data source and open file data source. So I've created my own data source before. You can just open the data source. This one I will share the data later in the end of presentation, so you can download the data and try the analysis by your own. Click OK. So the in within the data source, we as we can see here, we have two different data. The first one is the 3D point data, and the second one is the 3D line data. So these two data is represent pipeline data in such a real life. So now maybe we can have a look first how the data looks like by open them all in a new map. Okay, so it will be look like this. So one line, or we call it one edge, such as this one, it will in the each end of this line will have nodes. So this node and also this node, and that node is will be very useful for us to detect regarding the flow or the direction of the pipeline. So later on we will analyze based on the network, based on how is the direction of the pipeline. So we need to construct a network first, or otherwise we will not be able to do further analysis for the pipeline. So in the beginning we need to create a new network data set of our data. Before that, I want to show you the attribute table of each data. So such as here, this 5.3D is for the valve or for the node data. So it has rotation field XYZ, and then the symbol ID, and also the scale number XYZ. So these informations will be very useful for us to styling the valve, to styling the node in the end. So as you see here, the symbol ID, it has some number, right? So actually it corresponds with our library for top points. Maybe I will show you here in the SuperMap resources. You can have a check in the marker symbol library, go to the 3D symbol, and here in the two top points, every point symbol here, it has different ID to each other, such as this one, it has ID 54437, and this one is 54454 and 1. So by taking advantage, by utilize the symbol ID information, the symbol ID field that store in the 5.3D, we can style, we can change the style of the valve, we can change the style of the node, refer to the symbol ID to make it will look like this. Okay. Okay, now we go back to the presentation. So I have explained to you before, right? How can we detect the flow direction of the pipeline? So we need to construct a 3D network pipeline in the beginning, so that we will get the network data set, and from that it will store information. It will give you two data. The first one is the edge data, and the second one is the node data set, which store the from and to flow information. And each edge will have the node edge, and each edge in the end of the edge will have node that uh, useful for us to know the flow direction. I think there is a feedback here. Okay, next. So after we get the network data set, then we will try to visualize our data uh, by using the 3D symbol that's stored in the SuperMap. And so we are be able to create a new 3D symbol based on our requirements, such as give a give file on it so we can know the flow direction and other things. Okay, now maybe I will try this. Okay, so first we can go to the spatial analysis, and there is a structure network tools, and sorry, it should be in the traffic analysis because we are going to create a 3D network. So there is a network by topology, and we can have a click in the structure 3D network, and now you will be asked to define the node data, the edge data also. So in the node data, it should be the pipeline 3D, and in the edge data, it will be the pipeline 3D. And you also be able to change the reserved fields for both the node and the edge. So maybe should you have another requirements that will be willing to store or reserve certain field, you can have a further setting in these reserve fields for node and reserve fields for each, and also change the directory path for the result and change the default data set name here, and then click OK. And as the process finishes, so we'll get two different data. The first one is the line data set, and the second one is the node data set. So here I will open the data in this map. So actually it will look very similar with our previous data that haven't been created the network dataset before. But the different things that if you have checked in the attribute table, it will have two new fields, the SMF node and the SMT node. And in the SMF node, it represent the from, and T is for the stand for the two. So by utilize these fields, the SMF node and SMT node can know the direction of the flow of the pipeline. Okay, next. Um, Now I will open this data in a spherical scene. Okay, and this is how the data looks like. Okay, I will go back to the presentation again. So we will change the style of the pipeline. So first we will change the style for the pipe by creating a new 3D symbol and add give file on it so we can know the direction of the symbol. And also we will change the style, the symbol for the node or for the valve, and based on the information that already stored in the rotation field, in the symbol ID field, and in the scale field. And the last result will look like this. So we will get the 3D symbol of our pipeline and also get the 3D visualization for the valve, and we will add a row give file for the pipe so we can know the direction of the pipe. how to achieve that. You can change the style of the pipe first. You can right click in the pipe layer, the radio line network layer style, and we will create a new symbol. Okay, here in the interactive editor, you can choose the circle one and draw circles start from the center of the area, and then it will look like this. And next is we will add a GIF file. So this GIF file is it has green arrow illustration that will be very useful for us to know the direction of the pipeline, to know the flow of the pipeline. Then click OK, and it will be stored here. And we can change the width into 0.3 and click OK. Okay, and it will go like this. And now we change the altitude mode. So it it we can change it into absolute and set the data from underground, and then we can turning on the underground mode into open, and so that we will be able to change the transparency number. Okay, so if you don't change the transparency bar here, you will not be able to see any object underground. So you need to change the transparency first, so that then you can know the object underground. Maybe we can set it into 80%, and this is how the data looks like. So there's a elevation difference, right, between this valve and this valve and this pipeline. So that was because of the data were located in the different elevation, because for the valve, for the node, we haven't set the elevation yet. Sorry, I think there is an issue regarding my voice, and I don't know if you heard it well, but I'm not sure, because I already set the microphone as microphone in at front panel, but still give me the echo.
Hah? Kalau echo? Iya.
That's okay. I think this one is better. Okay, I will continue the presentation. So next is we will change the style for the valve. So for the valve, as I told you before, we will change the style. It refer to the information of the symbol ID, the rotation, and also the scale. Okay. And to do so, we need to create a new thematic layer of our node layer. You can right click and create thematic map. And choose the custom map and select the default. Click OK. And now okay. And now we can right click in the thematic layer and go to the modify thematic map, and you will get this window, the thematic mapping window. So here we can define the symbol ID, the rotation value, and also the scale. So here in the marker symbol, you can select the symbol ID, and then for the rotation, you can select the rotation X, rotation Y, and rotation Z. And in the marker scale, we can select the scale X, scale Y, and scale Z. And now click apply. And okay, still look at it, not it should be. So we can change the elevation altitude mode into absolute and data from underground. So it will be located in it's supposed to be here. Okay. Okay, now we go back to the presentation. So we have successfully tried to set a model for the data, change the symbol, create a 3D new symbol, and also give a flow in illustration for the pipeline. So next part is regarding the analysis. So in one of the analysis provided by SuperMap for pipeline is the single tracing element analysis. So it will perform the tracing analysis for a specified node or edge according to the network direction. So it provides four different analyses. The first one is the trace upstream, and then the trace downstream, the find source, and find sink. Before we move to IDStop again, I will give you a brief explanation first on each analysis. So in trace upstream, it will look up all the upstream edge that flow into the specific node or edge. So let's say we put the point or the selected point, this one, the yellow one, and then it will show you the result of the upstream edge, the all of the upstream edge that pointing to your selected point. And for the downstream is the vice versa. So after you define the point located here, for example, the yellow one, and then it will show you the downstream area, the downstream pipe that pointed from the selected node. And also in the find source and find sink, actually for the find source, it's quite similar with the trace upstream, but the difference is that for the trace upstream and trace downstream, it will give you the whole result. So let's say if one point is has two or more than two different upstream source, it will be show all of them, the trace upstream and trace downstream. But for the find source and find sink, it will give you the farthest source with minimum cost. So here, for the today tutorial, I will show you with the cost is the length for today. So find source and find sink is to give you the farthest sink or the farthest source with minimum cost, while for the trace upstream and downstream is will give you the whole result. So maybe if you have more than one path, more than or maybe around two, three or more about the trace, it will give you the whole result. Okay, now let's take a look how the analysis done in IDStop. Okay, so in traffic analysis, sorry, spatial analysis, and within the facility network analysis, you can find a single element traces analysis. So after you click on that, you will get two different windows, the environment and also instance management. So in the environment, um, you can do some setting for the regarding the pipe rules, such as set the weight, set the node field ID, tolerance or another things such as this one, the rules setting or the turntable or this one is will be useful for the last part, the burst analysis. So for today, for now, we will not try this one and another setting. So we will go directly to analyze the data. So here, if you have a check in this button, you can first change the feature type. So if you use node as the feature type, you need to put your points in your node. Or otherwise, if you put your points not in node but in edge, the software will automatically move your points into the closest node. And if you use edge, you need to put you need to select the edge that you willing to analyze. But for today, we will use the node as the feature type, and in the analysis type, we can select either the trace upstream, trace downstream, find the source, find the sink, or yeah, maybe for in the beginning I will use the trace upstream. Click OK, and your mouse will be changed into like this, into like a plus symbol. And now let's select one node, say this one, and click execute. So in this node, we analyze the trace upstream, right? Trace upstream. So it will give you result like this. So trace upstream means that the resource, the upstream source of this edge is coming from this one, only one source, because you only get one trace, right? But maybe for another case, maybe some of the fault is has more than one fault source. It will show you the whole result. But for in this case, this node is only have one upstream source. And now let's take a look if we analyze the trace downstream. Click execute, and it will give you this result. So this is our point, the yellow one, and it will go to here, here, to here, and to here. Okay. Okay. So okay. So this is how the result. Sorry, previously I have internet issue, but I already solved them. Now I turning on my microphone again. Okay. I will repeat my last part. So this is our point, our selected point, and it will keep the flow from this point into this pipe. Okay, now we can change to another analysis. Find the source. Find the source is quite similar with the upstream analysis, but it will only give you one path that with the minimum cost, and such as this one. And because of this point is only have one source, so it will be similar with the result of the upstream analysis. And now we use the find thing. Okay, so previously, if you remember the result of the downstream analysis, it you will get more than one result, right? More than one path. But for this, since in the finding will only give you the minimum cost, the farthest and minimum cost, the cost for this case is the length, because in here in the environment we already set the cost or the weight as length. So that's why the result is based on the length cost. Okay, now we go to the another analysis. Okay, the next part is the critical element analysis. So this function is to find the critical upstream or downstream element nodes closest to the specific node or edge, as well as the downstream edge influence. So actually, will be very useful for maybe in case you have a burst point and you want to know which are the source of this burst. And by using the upstream analysis, you can find the source fault of the specific node of the specific burst point, for example, and trace the affected pipe. And for the downstream, you will not get the source fault result, but only get the information of the affected pipe. So the main difference is only for the source fault. So in the upstream, you will get the source fault information also, but in the downstream, you will only get the affected pipeline. Okay, now maybe we can directly try the critical facility analysis. So here you can change whether to do the upstream facility or the downstream facility. Okay, and click OK. See this here. Okay, so we define our points here, and in the critical upstream facility, it will detect our points here, right? And it will detect the source. The source, it should be here, the blue one, and the red line is represent the affected area. And if we do the downstream facility analysis, it will only show you the affected area, this one. While in the upstream, it will give you the the source and the trace before the source, such as this one. Okay, and now and the last part. So in the critical element analysis, so should we know which fault is act as the source, we then can do some prevention, such as close the valve so that it can reduce the risk of the valve of the flow affected to the selected pipeline. And the last one is the burst analysis. So this function is used to find the valve that is closest to the burst exceeding point from the upstream. So basically, the in the burst analysis is the analysis itself is quite similar with the previous one, with like such as the critical elements analysis, single tracing element analysis. We can find this analysis as well in the burst analysis. But one thing different is that in the burst analysis, we we can do styling easier because of this. In the burst analysis, we can directly do some setting to define the pipeline information that have correlation for the styling, such as about the marker symbol, about the scale, the rotation value, so that it will give you directly the pipe model 3, the pipe 3D model, and after that do further analysis for that. Okay, and the analysis that provided is the closest valve, the critical downstream facility for burst point, and downstream facility closest to valve. Okay, now I will go back to the ID stop and I will open my data in new spherical scene again. It will be look the same like before, but in the spatial analysis, I will do the pipe burst, and there's a question, there's a prompt message that this function needs importing the symbol library. So yeah, of course we need to click yes because we are going to style the valve later on. Okay, and it will automatically set your data to be underground and change the, and because it haven't been styled yet, you need to define the information first. In the environments, you can set the pipeline layer setting. The join model, it should be the symbol ID. Sorry, the pipeline model is the I think it should be, we need to set this one first, the pipeline model, sorry. So here we need to define the node ID, the valve ID, the start node, the end node that it store in the SMF and SMT node, and then the symbol, the marker symbol, the scale, and also rotation value. Click OK, and it will update your attribute table, and this will be the result. Maybe we can change some setting on it first. Okay, so in the 3D line, it actually using this symbol, so we can have a change by edit symbol, and do refresh. Okay, oh, I think that's no problem. So we can analyze further now. So after you successfully build the pipeline, so it will change the style of your pipe because you have set some parameters here, right, during the pipeline building modeling. And now in the instance management, it's just like before. We can select some analysis we are going to analyze, whether to find the close valve, the critical downstream nodes, the downstream facility to for burst point, and or the other one is the find downstream facility close to valve. Click OK on, and also don't forget to define the valve ID field, or otherwise you will not be able to achieve the result. Click OK, and now let's say we will put our point here. So this is the burst point. So maybe let's say we have a burst exceeding in this point, and now we analyze the result, and this is how the result will looks like. I think we need to change the transparency to make it more convenient, this one. So in this burst point, the source is this valve, and it will affect it to this part, and also to this part of the pipeline. Now let's try another point. See here. So the source it will be this one, and the rest are the affected pipeline. Okay. So we have tried the whole analysis for today, including the single tracing analysis, the critical element, the pipe burst analysis, and also try to symbolize our 3D 3 point and the 3D line pipeline, so we will be able to know way more better, way more experience in knowing how it will look like in kind of real life because we try to represent them in 3D way. And should you willing to try the whole process by your own, you can download the material in the link I put in this presentation in the bit.ly smc web underscore material too. And you can submit your result to the link I put in this presentation as well. And if you submit your result, you will get certificate from us, and it will be sent after you successfully submit your result. So I think that's all for today. Thank you so much for your attention. Thank you for joining our SuperMap mini classroom, the volume 10. This is our 10th webinar, and don't forget to join the next SMC. Goodbye and see you.